Hi guys, my name is Manasi Thakkar, and in today's video we are going to talk about LeetCode problem number 378. So the problem is that you're given a sorted matrix and we have to find kth smallest element in this matrix. So this is the first, second, third, fourth, fifth, sixth, seventh and eighth. So you also have to take care about cases where you have duplicates in the matrix, because it says that you have to find the eighth smallest element in the matrix and not the eighth distinct element. So if it was eighth distinct element, it would have been 15, but we are trying to find eighth smallest in the matrix, right? So it's really important to understand the question before you try to find a solution to this. So the first thing that came to my mind when I was trying to solve this was, how about at every point you look at the value to the right of it and you look at the value to the down. So if you're at 1, you look at 5 and 10 and you see that 5 is the smaller one. So you would go to 5. At 5 you check 9 and 11 and you see 9 is the smaller one. So you would go to 9. At 9, since you can't go anymore, right, you look at the down value and that's 13. So you would come down, and that's what's wrong with this method, because after 159, the fourth smallest value should have been 10 and not 13. So if you go and try to do it this way, it fails. So we are now going to look at the solution, and if you have seen if you have done more of this kind of problems where you have to find kth smallest or kth biggest and things like that, you would know that you have to use something called heap. Now in Java, we are going to use min-heap, because we are trying to find smallest element. So anytime you have to find smallest element, we can think of using a min-heap, so that you take out the first element from the heap and you know that's the first smallest element. You take out the second and you know the second smallest. And if you do that 7 times, you have taken 7 smallest elements out of the matrix. And now the 8th time when you do that, you're sure to have the 8th smallest element in the matrix, right? Because min-heap, whatever you add in there, the smallest will be in the top. So you should already know what the heap is. If you don't, I would recommend go and look how heap works before you continue with the problem. So we are going to use heap now. I was trying to solve it. The first time when I saw it, I didn't know how we can use heap to solve this problem. I was thinking about adding all the elements and then taking things out, but that's really expensive. You can't add all the elements, because with heap it's log n every time you add to heap and every time you remove something out of heap. So we're going to try to do something a bit more efficient than that, and so the strategy that we are going to do is add the first row inside your heap. So the first time you add it, your 159, every time you take something out of the heap, we are going to look at the x and y coordinates of it, and we are going to add the next row and the same column elements in the matrix. So I will use a custom class that has the row and column and the value itself. That will hold the row, column and the value itself. Every time you take something out of that priority queue, we are going to check what the x was, so what the row was. And if the row was 0, you would add the row of 1, same column, whatever the column was. So in this case, if you take out 1, we would add 10, because that's a row 0, column 0. So the next element you have to add in your matrix, in your priority queue, is the row 1, column 0. Okay, so let me walk you through how we are going to do this. Let's say we have added 159. Now that's my row, that's my column, and that's my value itself, right? Column 2. So that we have in the matrix, it's already sorted, so that's how it's going to look like when you add it to your min-heap. The first time you take something out, that's going to be 1. So when you take 1 out, we are going to add row plus 1 and same. So at 1, 0 we have 10. So we added that to priority queue. That's already sorted, so 5 will be on top. When you take 5 out, we are going to add row plus 1. So 0 plus 1 is 1, and 1, which is going to be 11. Then the second time you take it out, we are going to add 1, 2, which is 13. The fourth time you take something out, that's going to be 2, 0, which is 12. The fifth time you take something out, that's going to be 2 and 1, which is going to be 13. The sixth time you take something out, so the sixth time you take something out, it's going to look like this. So 12, 2, 0, 13, 1, 2, 13, 2, 1, right? So the sixth time you take something out, it's not going to be this, it's going to be that. You add one element the next row and that same column. Now if you see, we are already in the second row. We cannot go any further, right? So you cannot add it, so we would just skip it. We can't add anything. So the seventh time you take something out, that's going to be that. And the eighth time you take something out, that's our result. That's what eighth time when you take something out, it's going to happen. So again, just a pseudocode, add the first row in your priority queue. Every time you take something out of the priority queue, add the next row, same column value inside your priority queue, pick something out again, and do that for k-1 time. Whatever is left, the kth time you take something out, that's your answer. So that's what we are going to do. And if you notice, the priority queue, size of the priority queue will be equal to the number of columns we have in the matrix. So I hope that's clear now. Code is simple because you have a custom class, you implement a comparable interface, you override the compare method, and then we add that to the priority queues, and then you take it out from the priority queue. Yeah, if you guys have any other questions, please let me know in the comments down below, and I will see you in the next video.